The highest tides in the world occur between Nova Scotia and New Brunswick in the Bay of Fundy. Each day, there are 2 low tides and 2 high tides. The chart below contains tidal height data that was collected over a 24-hour period. In Part A, convert each time to a decimal hour. The times are given based on a 12-hour clock. This won't work for analysis, so we need to convert each time to the decimal hours elapsed since midnight. "2:12 a.m. is equivalent to 2.20 hours. Leave the hour value unchanged. Divide the minutes by 60 to get the decimal hour equivalent, 0.20. The decimal hour is 2.20. 8:12 a.m. equals 8.20 hours. "2:12 p.m. should be converted to 24-hour time by adding 12 hours. This gives us 14:12, which is equivalent to 14.20 decimal hours. 8:12 p.m. should be converted to 24-hour time by adding 12 hours. This gives us 2012, which is equivalent to 20.20 decimal hours. In Part B, graph the height of the tide for 1 full cycle. Bring up the table we completed in Part A. Time is the independent variable, so it goes on the x-axis. Height is the dependent variable, so it goes on the y-axis. The length of one day is 24 hours. Set the view window to x min equals 0, x max equals 24, and x scale equals 4. The height of the water varies from 3.48 meters to 13.32 meters. Set the view window to y min equals 0, y max equals 16, and y scale equals 2. Plot the points. We can draw a complete cycle using just 3 points, so the 4th point is not required. In Part C, write a cosine function that relates the height of the water to the elapsed time. Bring up the table in the graph. The minimum is 3.48 and the maximum is 13.32. The amplitude is A equals max minus min over 2. Plug in 13.32 for the maximum and 3.48 for the minimum. The amplitude is 4.92. The vertical displacement is d equals min plus max over 2. Plug in 3.48 for the minimum and 13.32 for the maximum. This gives us d equals 8.40. The period of the graph is 12 hours. We can find this by subtracting the leftmost time, 2.20, from the rightmost time, 14.20. The b value is pi over 6. There is a phase shift of 2.20 hours right. Plug the parameters into the general cosine formula, y equals a cos b theta minus c plus d. The independent variable is the time t, and the dependent variable is the water height h. The function is h of t equals negative 4.92 cos pi over 6 times t minus 2.20 plus 8.40. The cosine graph is upside down, so use a negative. In part D, what is the height of the water at 6:09 a.m.? Bring up the graph and its function. Before we can answer this question, convert 6:09 a.m. to a decimal hour. (6:09 a.m. equals 6.15 hours. Leave the hour value unchanged. Divide the minutes by 60 to get the decimal hour equivalent, 0.15. The decimal hour is 6.15. We can find the height of the water at 6.15 hours by evaluating h at 6.15. In method 1, we'll evaluate h at 6.15 directly. Plug in 6.15 hours for the time. Evaluate to get 10.75 meters. This is the height of the water. In method 2, use technology to find the height of the water. Set the view window to x min equals 0, x max equals 24, x scale equals 4, and y min equals 0, y max equals 16, and y scale equals 4, and draw the graph. Use second trace value with x equals 6.15 to get a tidal height of 10.75 meters. This is the same result we obtained in method 1. In part E, for what percentage of the day is the height of the water greater than 11 meters? For this question, draw the second cycle of the graph. Draw the line y equals 11. We need to determine the total time the graph is above this line. To find the points of intersection, we need to solve the equation shown. The height of the water is 11 meters, so replace h of t with 11. Use technology to find the intersection points. They occur at the times 6.26, 10.14, 18.26, and 22.14. Subtract the first two times to get 3.88 hours. Subtract the next two times to get 3.88 hours as well. The height of the water is greater than 11 meters for 7.76 hours. This can be found by adding the two times 3.88 hours and 3.88 hours. Divide 7.76 hours by 24 hours to get 0.3233. The water is higher than 11 meters for approximately 32.3% of the day.